Welcome back, everyone. Today, we're going to be taking a deep dive into some cutting-edge research in AI.
Okay.
Specifically, we're looking at how large language models, or LLMs, might be capable of reasoning without relying solely on language.
Yeah.
I know it sounds a bit paradoxical, but stick with us.
Right. It's a fascinating area of exploration.
Yeah.
We often think of LLMs as these word processing machines, but what if their true reasoning potential lies beyond language?
Exactly. And that's what makes this new research paper, Training Large Language Models to Reason in a Continuous Latent Space, so exciting.
Yeah.
It introduces a novel method called COCONUT, short for Chain of Continuous Thought.
Okay.
That really challenges our assumptions about how AI can reason.
It's a departure from the traditional chain of thought prompting, or CT, where LLMs solve problems by generating step-by-step solutions in natural language.
Right.
COCONUT, on the other hand, allows the LLM to manipulate information in a continuous numerical space, almost like letting a calculator do the work instead of having to write out the equation.
That's a great way to put it. So instead of forcing the LLM to think in words, COCONUT lets it work with information in a more abstract numerical form.
Right.
How does that actually play out in the model?
Well, imagine the LLM is working on a reasoning task.
Okay.
In COCONUT, the last hidden state of the model, which essentially represents its understanding of the problem at that point, becomes this continuous thought.
Okay.
Now, instead of decoding that hidden state into words, like in COCONUT directly feeds it back into the model as input.
So it's like the AI is building up an internal understanding of the problem, but it's not limited to expressing that understanding in words.
Precisely. It's operating in this richer, multidimensional space, which could potentially allow for more nuanced and efficient reasoning.
Okay.
And the results presented in the paper are really intriguing.
Yes, the paper shows that COCONUT can actually outperform Coqui on certain tasks.
Right.
Particularly those that involve complex planning, like those tricky logical reasoning puzzles.
Right. And not only does it perform better in some cases, but it's also more efficient.
Okay.
The COCONUT uses fewer thinking tokens during the reasoning process, which translates to less computational effort to arrive at a solution.
That efficiency aspect is definitely noteworthy.
Yeah.
I'm also quite fascinated by this idea of breadth-first search that the paper mentions in relation to COCONUT. Could you elaborate on that a bit?
Absolutely. One of the most surprising findings was that COCONUT seems to implicitly perform a kind of breadth-first search.
Okay.
Instead of committing to a single line of reasoning like COTI often does, COCONUT can maintain multiple possibilities within that continuous thought.
So instead of going down one specific path, it's exploring multiple paths simultaneously, almost like branching out in different directions.
Yes, exactly.
Yeah.
And as the reasoning process continues, it gradually eliminates incorrect options, narrowing down the possibilities until it arrives at the solution. This flexibility seems to prevent it from getting stuck in dead ends, which can sometimes happen with COTI.
That's a really clever mechanism. But if these continuous thoughts are essentially just numbers, how can we understand what's going on inside the model? It seems a bit like a black box.
That's a valid point. While the continuous thoughts themselves aren't really meant to be translated back into language, the researchers did attempt to decode them for analysis purposes.
And what did they find? Did those decoded thoughts make any sense?
In one example, they decoded a continuous thought for a math problem, and it's quite remarkable the decoded thought actually encoded the intermediate variables of the calculation.
Wow. So even though it wasn't explicitly writing out the steps, it was still performing them internally in this latent space.
Exactly. It provides a fascinating glimpse into how COCONUT can represent and manipulate information in this numerical form, and it really challenges our conventional view of AI reasoning.
Absolutely. The paper also emphasizes that while COCONUT uses this continuous latent space for reasoning, it can still communicate its findings in natural language when needed.
Yes, that's a key point. It's not about replacing language entirely. Language is still crucial for us to interact with and understand AI, but this research suggests that language may not be the most efficient way for AI to actually perform the reasoning process itself.
It's like giving AI its own internal language for thought, which is separate from the language we use for communication.
Precisely, and just like different human languages have different strengths and weaknesses, it's possible that this continuous latent space might be better suited for certain types of reasoning tasks than languages.
That raises an interesting question. What types of tasks might benefit most from this kind of non-linguistic reasoning?
Tasks that involve complex planning, spatial reasoning, or abstract problem solving are likely to be good candidates. These are areas where traditional language-based AI systems often struggle.
It makes me think about fields like mathematics, physics, or even art. Imagine an AI that can discover new mathematical theorems, model the behavior of subatomic particles, or create truly original art, all by reasoning in ways that are beyond our human linguistic capabilities.
Those are certainly exciting possibilities, and it's not just about specific applications. It's about expanding our understanding of what AI is capable of and how it can complement human intelligence.
The paper also touches upon a fascinating connection with how human brains reason. It mentions that brain imaging studies have shown that language areas aren't always heavily involved in complex reasoning tasks.
That's right. It suggests that our human brains might also be utilizing non-linguistic representations for certain types of thought. So in a way, this research isn't just about creating smarter AI, it's also about understanding ourselves better.
It's like by exploring these alternative models of reasoning, we're gaining insights into the fundamental nature of intelligence itself, both artificial and biological.
Exactly. It really blurs the lines between computer science, neuroscience, and even philosophy. It speaks to the transformative potential of AI research, not only to create new technologies, but also to advance our understanding of the world and ourselves.
Now, the paper also delves into the challenges of training Coconut. It mentions that the researchers had to use a multi-stage curriculum to gradually transition the model from reasoning in language to reasoning in this continuous latent space.
Yes, that's a crucial detail. It highlights that we can't simply expect AI to magically learn to reason in this new way without proper guidance. It requires careful design and training methods.
It also raises the question, are there even better ways to train these models? Perhaps we need to develop entirely new learning algorithms that are specifically designed for this kind of non-linguistic reasoning.
That's a great point. It's still early days in this area of research, and there's so much room for innovation in terms of training methods, architectures, and applications.
The paper also touches on the issue of interpretability. Right now, these continuous thoughts are a bit of a black box. A more intuitive way to visualize and understand these spaces would be incredibly valuable.
Absolutely. It would not only help researchers further improve these models, but it would also be crucial for building trust and transparency around AI systems that reason in ways that are less human-like.
So as we wrap up our deep dive into this fascinating research on AI reasoning beyond language, what would you say are the key takeaways for our listeners?
I think the main takeaway is that we're only just beginning to explore the true potential of AI. Exploring these non-linguistic reasoning capabilities could lead to incredible discoveries and fundamentally change how we interact with and understand artificial intelligence. It's a journey full of unknowns, but that's what makes it so exciting.
It is. This pursuit of understanding the limits of intelligence, both human and artificial, is what drives us forward. As we delve deeper into these uncharted territories, who knows what we might find? Perhaps entirely new forms of intelligence that could reshape our world. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.